I forgot how to start these off. I really need to name this series other than developer workshops. I need something catchier. But anyways, I'm Emily. I do DevRel for Linea, but really what I'm here for is to invite these lovely faces from IoTeX here to learn more about building decentralized bike sharing networks. Just like really sexy sounding. So I'll let you guys introduce yourselves.
Sure. Simone, go ahead if you want to.
Yeah, I am Simone Romano, working at IoTeX as a developer relations manager. Giuseppe.
Yeah, I'm Giuseppe, and I work DevRel as well with Simone. And yeah, we're really excited to be here. We obviously, we've been working at this series for a while. This is like fourth episode, but yeah, I guess we'll unfold little by little and talk about this a little bit more. Yeah.
Yes. Oh, that's a great segue. We are episode 4, correct, of your series on building with IoTeX. Is it let me rephrase. Let me start over. This is not my series at all. We're co-hosting it with these wonderful guys over here. So I don't need to worry about naming my series. I just need to worry about you guys naming yours. Is how it is. But before we dive into the actual building portion, I guess we should probably just start with like introductions on like what IoTeX is.
Yeah, for sure. I had actually prepared a couple of slides. I wanted to sort of like
Yeah.
intro like some of the concepts that we're going to look at today, and basically where IoTeX fits in this picture, and then pass the ball to Simone for like the more hands-on part,
Yeah.
if that's okay. But like in general, like just to give an intro to maybe all of like your audience that doesn't know what we're up to. Since we've been working with these like physical infrastructure networks and how to build them, we decided to basically create a series of live streams where we would basically build the project end to end, tackling different aspects of building such projects. Maybe one episode we talk about smart contracts, one episode we talk about the overall general architecture, the token economy of such a deepen project. I'll go into what deepen is in just a sec, but just bear with me. And so, yeah, this happens to be episode 4, and we wanted to talk about scaling, and we wanted to talk about what we've been doing so far could be potentially integrated with Linea as like the DApp layer, and how our tech could help scale such an application on top of what already, like Linea is going to scale sort of like the on-chain part, and our infra sort of like scales the off-chain off-chain part. We're both using ZK for that, but we'll get all in just a sec. That was just a little bit of context for how we arrived here. I'm gonna maybe start sharing my screen and just show a couple of slides and start talking about this in a little more detail.
Yes, absolutely. Visuals are very
Cool.
much appreciated.
Right. Let's see. Screen share, window. We're gonna do this. And if I do this now, you guys can see my screen?
Yeah.
Awesome.
Absolutely.
Cool. All right. So as I was saying earlier, IoTeX is focusing on empowering these projects that require some sort of like physical proof of physical work, right? And there is an acronym for such projects. It's DPIN. DPIN stands for Decentralized Physical Infrastructure Networks. And there are types of projects where there is some sort of like token incentive that is used to reward network providers for a service that in turn then benefits the general community or end users. As you can see in this map, there are obviously different categories, right? There are several blockchains on the top right that have been in this space, like Ethereum, Solana, IoTeX, and etc. There is some physical resource network, wireless, digital resource networks, and within them there are all sorts of like subcategories. And then there is this raw in the middle, the purple one, which is deepened modules. And these are basically projects that are sort of like creating various modules that can be used within a deepened infrastructure. So just to give a more concrete example, there is this thing that's called the deepened network flywheel, where essentially what it's doing is basically saying, okay, as you increase the sort of like the demand for set network, then as the network grows, it will then, and the supply grows, then it will then in turn create more demand for the network, etc., etc., etc. I'll talk about this in just a sec. I just want to give a concrete example. There are projects like Helium, for example, being one of the best known deepen projects out there. And so the way it works on a very high level is where people are incentivized to basically provide connectivity, right, through these routers. And then the end user can then enjoy the benefits of these, of this decentralized network. And the people that are actually providing the service, the connectivity, are then rewarded in some sort of token. And basically, that's how all these projects work. So the cool thing is that these projects are basically based on something real world that is tangible. That's why this was such a great sort of like niche for IoTeX, having been working with the intersection of IoT and Web3 and all the research and all the stuff that the team has been working on for years. So just to get into a little bit more detail with this flywheel, I tend to often start from community, because I think it's one of the most, the coolest thing that the Web3 brought, into the mix. And so when you think about community, and you think about maybe building a project, let's say this little bike sharing project that we are creating, we start creating this community, we build it up, then maybe we start raising some capital because there is interest about these projects that we're building, and our community is really strong. Then with financial capital rolling in, the token that we're using to reward the network providers, which in our case are these the owners of these bikes that basically they contribute to the network of bikes, the token value starts increasing. And as it increases, now we're going into the bottom right, there will be more miners interested in actually mining these tokens, and deployers actually interested in this platform, which will then basically trigger these third-party developers to keep on building on this network, which will then increase the utility. And now we're on the top left, which then will benefit the end users. The more end users benefit, the more buzz there will be, the more the community will grow, and the wheel just keeps on going. And this is basically the deepen flywheel. So I just want to make sure I'm not alone there. You guys are there, right? Okay, good. Because I can only see my screen. I cannot see if maybe the connection got lost 15 minutes ago. And I just wanted to make
breathe
sure.
loudly.
Exactly. Awesome. Oh, great. Thank you for that. So to build a deepen, there are definitely various things that come into play. Like I was saying earlier, there is like the IoT element, so hardware devices. There is how do we compute this data that is coming from these devices in a way that then can be sort of like ingested into a smart contract. And how can we do so in a verifiable way, right? Because why would you trust random devices that just send data to your network, and especially when there is a token incentive attached to this data, right? So after the distributed computing, which we'll talk about in a little bit, which is kind of what we want to focus on today, then we have these smart contracts where the trusted logic and the orchestration of the token economy, and maybe the source of truth for our application layers. Then we have decentralized identities, because we got to think that, like, a device has its own identity, a user in the network has its own identity. Sort of like in this case, we will have bikes having their own ID, which then is attached to an NFT. But Simone is going to talk about that in just a minute. And then we have the token economy layer. Token economy, basically, how are these network providers incentivized to keep on basically providing this service for the network and for the end users, and how are we sort of like governing this in a decentralized way, etc. So on a personal note, all these sort of like components are really interesting, and I think it's sort of like the coolest thing about Deepin. And I say that, whenever I get a chance to like maybe talk in like a space or like in an MAA or like talk to the community, I feel that Deepin is sort of like bringing all these interesting components together. It's sort of like the perfect mix of like Web3, tokenomics, on-chain logic, off-chain, ZK, decentralized identity. There is AI. There are AI projects, real-world devices. It's sort of like a very interesting mix, right? And so, where does IoTeX come into play, right? We were talking about maybe earlier about introducing IoTeX, and these are sort of like, thank you for the by the
Yes.
way.
I felt like it was less offensive than a deep breath.
Deep breath could also mean like, oh, I'm so bored. Oh my God.
No, never.
And so where does IoTeX come into play, right? So we, as I was saying earlier, we offer this like modular infrastructure where basically there are all these various services that people can use to build their own projects, right? So we start from the bottom layer, which is the layer 1 blockchain, which, again, as I was saying, is sort of used as a common source of truth for a project, and it's intertwined with the architecture and orchestrator of this like middle layer, which we will talk about more in just a second, right? Then we have all these network tools like developers portal, like IoTube bridged, IoPay wallet, which support Deepin tokens, liquidity for Deepin projects, etc., etc. We have this middleware, which is what we'll talk about more today, which is WebStream, which is where the off-chain computation of all this raw data and all the scaling of all this raw data is done. And that comes with its own services. And then we have the hardware layer, where we offer already Web3 native devices, such as the UCAM Pebble Tracker and the Deepin Dev Kit. That's the top left. We have embedded SDKs for basically people to use sort of like, boards like Arduino or Raspberry Pi to basically contribute to a network. We have mobile SDKs and then device IDs, etc. So the goal is to just give builders this opportunity to leverage whatever they need specifically for their project to then, create a successful Deepin project. So as I was hinting at earlier, today I wanted to focus on this WebStream layer, which is this middle layer where this verifiable computation happens. So before we get into this, I think it might make sense to have a look at this, right? And so this is the architecture, more or less, of what we're going to do today. We have this hardware layer, which in our case are these bikes. These bikes are sending data, and they're sending data to this IoTeX Deepin infrastructure, which is basically the layer 1 chain plus this WebStream. And WebStream is basically like this decentralized network that kind of works as a layer-2 rollup, but for this raw data. So the raw data comes in, and then a ZK proof is computed, and then this ZK proof is sent to a DApp layer, which can be, where the smart contracts are, which can be IoTeX itself. it will be Linea in today's episode, Ethereum, Polygon, Solana, and whatnot. So the difference here is that like the IoTeX chain can be used as a DApp layer where the smart contracts are, but today we're going to use Linea. But it's also intrinsically working with the WebStream infrastructure to orchestrate these decentralized network of WebStream nodes that basically function as provers that will then spit these proofs to the DApp layer. And so how does WebStream work? Data comes in from these smart devices on the bottom left. It goes into this decentralized sequencer network. And this sequencer network basically acts as a sequencer, basically puts all these raw data together and then sends them to this data availability layer. Mm-hmm. The data from this availability layer is then batched together, and then it gets fetched by the aggregators on the right. And these aggregators basically compact all this data together and spit a proof to this layer 1 block. So it's working exactly as a rollup, but for off-chain data that's coming from these devices, which in our episodes, again, are the bikes. Basically, bikes send the data, said, hey, I finished the ride, or I start the ride. And Simone will go into more detail later about this. But this happens, all this data gets packed together, a proof is sent that says, okay, cool, Giuseppe finished the ride, this is how much Giuseppe owns, and this is how much the guy that owns the bike that Giuseppe used is going to get at the end of the day. Mm-hmm. And basically, that's it. So we sort of like verifiably can trigger the token economy based on this off-chain data. And that's about it for at least this intro that I wanted to give. And if people are interested, they can follow us on X on IoTeX_dev, and we have the dev Discord if people want to basically get in touch, etc. So I will stop here, and it's now time for
maybe I will let Emily have some time if you have any questions.
No, that's super cool. So just to this is my dumbed down summary of everything, right? So you guys are the layer in between
I think this layer stuff working is getting out of hands in the blockchain.
Yeah, okay. What's another way to put it then? You are the
I guess we are an infrastructure in very general words,
right,
for decentralized applications, I would say, which now I guess the blockchain space is evolving toward multi-chain, and then these different layers with these different roles in the space getting interconnected in more different ways. So it's very hard to classify at this point, I would say.
Yeah. Okay. Well, let me try to describe things without even saying the word layer. You help.
You can if you want, though. There's no.
This is a challenge.
It's not forbidden. It's not forbidden.
If bikes or hardware things want to communicate with on-chain interaction, so like a DApp, for example, IoTeX empowers that communication to happen.
Yes, actually, it's interesting to say to say some words about the intersection between IoT and blockchain. I'm sure everybody has heard for a long time about this talking IoT and blockchain, all the problems, the scalability, the privacy problem, the processing, I don't know, IoT logics and stuff, right? All these problems. We have been working for years. We even created trusted hardware as a result of our papers to prove how to design hardware to be Web3 ready. And then we have been working on the layer 1 to be fast, secure, reliable, as a layer for token economy, but also as a layer of trust in these types of applications. And so basically working on exploring and researching how to connect real world devices with blockchain applications and trying to overcome the problems, because usually you have, when you are talking IoT and deepin in this case, you have to think about million devices or even billion devices. There are stats about how many devices, IoT devices people have, and each one of these devices usually communicates millions of messages, each one. And so if you multiply and go devices by number of messages, by time, right? This is something that blockchain is just not built for, right? Blockchain is a layer of trust, is an authorization layer, a token economy layer, right? But it's not a data layer, it's not an IoT layer. So that's why we are building a full infrastructure with different modules, different components. One of these components, fundamental, is WebStream, which is this using, like, I would say, the rollup concept, but extended or abstracted to raw data, not just to blockchain transactions. So it's just rolling up messages from devices into blocks and then generating a single proof that basically says, okay, this block of thousands messages is valid. It's coming from authorized devices and it's been computed with some logic, and the result is this. It's valid, right? And sending this single proof on behalf of so many data messages to the blockchain application. And this has two advantages. One, scaling, right? Because I'm like rollup. I'm sending one verification element, a ZK proof, to prove thousands data messages. And second, you can have privacy because it's a ZK proof, and provided you're solving other problems in the layer 2 in terms of confidential computing, I'm not diving into it, but then you can also save privacy, because that's another important element of any IoT and also this deepin application. In this case, you can think of riders don't want to tell everybody where they're going, right? For example, or what they are, right? This is a simple use case. So just forget about sending this data to a blockchain. You need a middle layer that acts as a scaling layer and a privacy preserving layer for these types of applications. So that's what we are focusing on a lot, plus providing other tools and the other components like liquidity stuff, or tools like wallets or bridges, and more and more. So just we don't have enough time to dive.
Okay, yeah, 'cause I feel like IoTeX is a lot. I actually, honestly, I don't know that much about IoT, so, like, these problems that you're bringing up between IoT and, like, blockchain, I'm not familiar with, so thanks for, I guess, giving that little bit.
Yeah, it's interesting, I believe, to everybody. Just there are not so many projects working on it.
Yeah, we did have this one question, maybe just bring it up right now. Someone was asking, I'm not familiar with Theta Network, if you guys know.
Enables decentralized storage, compute, and data streaming.
I don't know what Theta blockchain has to do with this live stream.
Yep. Okay. Neither do I.
But I mean, in general terms, it's not like we're providing like a decentralized storage layer, or what else did
they ask compute and data streaming.
We are providing a verifiable processing for data. And then the result is a verifiable proof of something that happened in the real world that has been computed on top of this data, right? But we are not storing the data. The data can be stored anywhere else. It's just temporarily packed and verified into the IoTeX infrastructure for the purpose of computing a ZK proof. But then if this data is supposed to be permanent, then it's the application project role to decide where this data should be stored permanently. Could be a centralized infra, could be a decentralized infra, could be whatever, their own infra or whatever. But from our point of view, we're just fetching this data, packing it, verifying it, generating a ZK proof, sending the proof to the DApp for triggering the payment, the token economy, whatever rewarding token economy for maintaining the infrastructure in the real world. Maybe I can make the Helium example, right? That's the most obvious one. Helium people, they maintain the infrastructure in the real world by running their routers, right? So you maintain this router, this Helium rider, providing a service, this like connectivity service to other people. Other people use this service and pay for it, right? And so this payment goes through the token economy on the blockchain. The blockchain must know how much each router, how much connectivity each router has provided in general, and so send them proportionally the amount of payments to maintain, to incentivize them maintaining the infrastructure in the real world. And so this happens thanks to collecting data from these routers, processing this data, and eventually proving how much network coverage my router provided to the people, or how much I contributed to the infrastructure. And then the blockchain will send me the payment. So this part, where you collect the data, you process it, and you generate a proof of work in the physical world, is what is the crucial point in Deepin projects. And that's what we are scaling, right? Okay, I guess maybe we can go ahead. Otherwise,
we can do this for hours.
Yeah. Yes.
Maybe I can share the screen.
Yeah. Share your screen
and see where it takes us.
Cool.
Can you see the screen?
Yes, we can share the screen now.
Okay, excellent.
Yeah.
So, talking quickly again about this bike sharing example, right? We use this as just an example, just to make it easier for people to have physical or like a real use case to, think about these concepts and understand them better, and maybe mostly to inspire people to build something, not necessarily a bike sharing application. This is just an example. And we are using these episodes to just sometimes explain one concept, sometimes explaining, talking about token economy of Deepin, talking about, how to scale processing, like it's the case now, or talking about, sometimes how the hardware could be designed and programmed to work into these types of projects. So just to recap for the viewers who have not seen the other episodes, in this hypothetical bike sharing application, there is some authorized entity, maybe a factory or the project itself team that is in charge for creating the hardware, right? In this case, it's the bike that has the role of data collector, right? Or generating the data for whatever the service is in the real world. In this case, it's bike riding or bike sharing. And so most probably this bike is going to collect when a new ride is started, when it's finished, where or the locations where the person went, or how long in terms of time, how far in terms of meters, kilometers, right? And all this data related to bike sharing in general. And then on top of this data, we want to run some token economy, right? We want the person who bought the bike to be rewarded. We want the people that uses the bike to pay for it, and most probably build any other Web3, whatever composable element that you want to compose this application with. So, of course, you have some bike owner that at some point acquires a bike, and each bike in our example has a unique ID, right? Yeah, I'm not going into the specific details here. And also we assume that when you acquire a bike, you get a new NFT minted by the manufacturer that is also associated with that bike. So the token ID of this NFT is exactly the unique ID of the bike. And so you receive this NFT, which means you are the owner of the bike. And as the owner of the NFT, you can also interact with the DApp as the owner of the bike. For example, you want to suspend, right? For example, your bike because it's in maintenance, right? Or you want to change some parameters or whatever as the owner. And so this NFT proves you are the owner, so you can do that. And then at some point, there are bikes somewhere that everybody who is interested into investing, into maintaining this infrastructure, they buy the bikes, they put them on the street, and other people can be the riders, can be the end users, so they can use the service. So at some point, somebody goes on the street and says, okay, I want to use this bike now to ride to work or whatever, right? So how does this work? This is, again, just an hypothesis to inspire people to build some similar types of applications. It not necessarily is ready for production or anything, right? Just to give an idea. So most probably these bikes, or they are e-bikes maybe, right? They have some computing element, some device, some electronic, right? That makes this bike smart. Could be, for people who are interested, could be an ESP32 or some more industrial grade hardware. Most probably they have Bluetooth, maybe they have a GPS, maybe they have whatever, and today's e-bike have already, right? And we imagine that there is some Bluetooth on the bike and some internet connectivity on the bike. And most probably we have a bike sharing application, mobile application on a smartphone. And so let's see how this could work, right, in terms of flow. So I have a person who wants to use one of these bikes. So this person must acquire the mobile application, of course, and most probably they must acquire a bike token to pay, right, for riding the bike, for this infrastructure. That's the main token that maintains the incentives for the infrastructure. So this user wants to go somewhere and acquire the bike token, a certain amount, then download the app, the mobile app, then they see the bike, they scan the QR code, which most probably is just encoding the unique ID of the bike, right? And then they estimate a possible ride on the mobile application, maybe using Google Maps, whatever, and so that the mobile application can estimate the cost, the overall cost of the ride, more or less, and the mobile application will just sign a new ride message that is sent, in this case, to the app on the Linea blockchain, right? And this message is basically sending the bike ID I want to use, right, for riding, and I'm depositing bike tokens that should be enough for covering my ride, or maybe a little bit more, right? And so as a result of this transaction, the Linea layer the app will return in the transaction log a ride ID, a unique ride ID for this specific ride. At this point, the mobile application, of course, the user is close to the bike, otherwise he cannot or she cannot ride anywhere. And so the mobile application is just sending a message, maybe through Bluetooth to the bike, and say, hey, you should unlock, this is the ride ID, okay? And then the bike will just query the blockchain with the ride ID and say, hey, give me the ride information here. Most probably it could be how much the user deposited, so that maybe the e-bike doesn't allow you to ride more, or warn you that your deposit is not enough at some point, or whatever, right? That's also where users could maybe stake some tokens to give some commitment, right? That they do not go away, run away with the bike forever, or stuff like that. That this is up to the project developers how to maybe design some aspects of the layer one. And so the bike receives the deposit amount and just unlocks, and the person starts riding, go to the destination, and then at some point we'll use the mobile application to end the ride. Okay, that's exactly what happens in a normal bike sharing or car sharing application. Just there is some interaction with the blockchain token economy for the payment and for storing some trusted information. So when I end the ride, this is something that happens with the Bluetooth. I'm telling the bike, and I want to end the ride. You should lock, okay? And so the bike would just say, okay. The bike has collected data, right? I'm imagining that some of this data could have been already transferred to the IoTeX layer during the ride. But in this case, I'm just focusing on the final message. That's when I lock the bike, and then the bike will send a message to the IoTeX infrastructure saying, okay, this ride is completed. This is the ride ID. This is how long the ride lasted. This is the distance, and this is a crypto signature from the bike hardware that should match the actual bike ID or the public key of the bike that is registered on the blockchain. But again, I'm not going into these specific details. We have explored the trusted aspect of the hardware into past episode. If people are interested, just can take a look. So the bike is sending this one of these millions messages, right, to the IoTeX infrastructure, signing it with some whatever hardware like secure signature can be generated. Not necessarily blockchain signature, can be any IoT or signature, any crypto scheme or whatever is available on the hardware. And that's also where this infrastructure is important, because you don't know exactly, I mean, the blockchain not necessarily can verify any crypto scheme, right, for signature, while here you can do anything. So here the message is received, is packed by the sequencer, and at some point the prover will pack all these messages, verify all the signatures, and just generating a single ZK proof that is sent to the DApp, calling the end write function of the DApp, passing over the ZK proof and the actual write ID and the cost of the write that was computed here, based on the write time, the write distance, and who knows, whatever you want to have into your IoT logic. For example, have higher cost for peak hours, or I don't know, have based on more cost based on the location, whatever, right? Whatever is your IoT logic. And so this proof is sent to the Linea DApp, and that's when the DApp is settling the payments, right? It will just use maybe an additional layer of token economy on top of the cost and say, okay, I'm gonna, this cost eventually translates in so many bike tokens. And so it's just sending part of the deposit to the owner of the bike to pay for, like to reward him or her for this ride. And the rest, the change will be sent back to, if there is any, will be sent back to the owner, to the rider account, right? And this is overall how this application, this example could work. So eventually it seems complex, but it's eventually very simple.
Yeah,
it
there's
seems
lots of
complex.
arrows.
Seems
Yeah.
complex because maybe we're not familiar with using blockchain into real world applications. So this of course involves more concepts like hardware and some real world utility, real world activities and actors, right? That there are so many actors that could be involved into these types of applications. Like somebody could be the bike maintenance service, for example, right? And some other. Having everything on the blockchain allows you to compose this application with so many other, even DeFi applications. For example, as the owner of the bike, you could prove to blockchain DeFi applications your income, and then use this income into some DeFi, I don't know, even collateral sometimes, right? Depends on how you want to use it. So eventually it's just 3 simple components. One is a bike NFT, which represents the actual existing bike registered with its unique ID on chain. And we have also, I think, in the bike episode number 2, implemented such an NFT, how to use it, how to mint it, how to use it in a smart contract to actually verify you are the owner of a bike and so on. Then you have this custom bike ERC20 contract, which basically is an ERC20 contract, just allows you to settle this payment upon receiving a ZK proof and also starting a new ride with receiving a deposit of this token. And then there is the IoTeX WebStream prover, which is what is more IoTeX focused, and it's what actually generates, computes the cost of a ride based on the data and proves this with a ZK signature, let's say. So because we don't want this webinar to get too long today, and especially it's a little bit of coding, so it can be maybe overwhelming. So today we are going just to implement and deploy to the Linea layer the DApp, right? So this is just a simple NFT, just plain one standard that just represents the bike ownership and the actual ERC20 like token / the app, because it's so simple that it's enough to have a single contract for it. If there are no specific questions,
There's like a few questions. I think some people are actually interested in using it for themselves. So the first piece, just like having the presentation, access to the GitHub, everything that'll be provided. Yes.
yeah,
Yeah.
we are going to upload the code to GitHub, and maybe we can work together and update the video description with all the links.
Yeah, yeah. And then I guess the other piece too, I think they were asking is, can we integrate conventional sharing operators into the system? So I guess like integrate, it says rental fees with tokens. There's a lot
Yeah,
of
one.
creativity.
Yeah, of course. As I said, we create this content to inspire people and see what they can build, and even build it. Right? It would be
Yeah.
great. Would be great. Of course, for example, like here, as the project deployer, you can also, when you settle the payment, for example, you can take out a fee that goes into the contract, right, for the service that the contract, and this fee can go in a DAO, for example, right, and you can have a DAO of all the users involved into this infrastructure to take decisions about this fee or about any other aspect of the infrastructure. In terms of conventional or typical other existing infrastructure, would be great if they would want to integrate. So I guess any sort of project like this would be composable, would be open, and I guess it's on them to decide to maybe integrate their bikes or into such a service and use it.
Cool. And
So
then one last, it was just like, I think it was a previous person asking about, the data storage, I think to re-verify his understanding. So IoTeX allows IoT devices to communicate and share data in a verifiable manner with other network participants. That's
yes.
yes.
Yeah, this is accurate, totally accurate. So let's say that all this data here may even not go directly to IoTeX. Could go to the project infrastructure, can be AWS if it's a typical like half centralized, could be IPFS, or could be, I don't know what other data layer that they want to use. And then at some point, they are just sending the relevant data for the blockchain to the IoTeX infrastructure for generating the proofs those proofs that are needed to the layer one token economy to trigger some, economy on chain. You may not necessarily need to send on chain all the proving anything, but you want to prove those things that are useful for triggering the token economy. And the data that is needed for generating these proofs goes to the IoTeX infrastructure. Okay.
Cool.
And as I said, goes to the IoTeX infrastructure, but it's not staying here. It just goes to the infrastructure for the purpose of generating the proof. But this is not a storage layer. This has interfaces with storage layers to fetch the data. Cool. Okay. Eventually, let's maybe just do some coding for fun.
Yeah.
I had the pleasure of experimenting a little bit with the Linea. Seems very seamless, simple, easy to use, pretty EVM stuff and Ethereum stuff. So what I did, I see no point to create a complex project or stuff. Just it's two contracts, very simple. So I'm doing them directly, coding them directly in Remix ID. So what I did, just connected my MetaMask to the Linea, just switched on the show the testnet, connected to the Linea Girly testnet, and I acquired some test tokens in my account. Make sure you switch to the Linea Girly network. And then in Remix ID, what I did, one thing I had to do was to go to the compiling section, advanced configuration, and I had to select the EVM version to Paris. Emily, tell me, stop me if I'm saying anything wrong here. I'm not the expert.
Yeah.
So
We don't support 820 onward because push 0 is not covered yet, if people don't know that. So yeah.
Okay, great. So you select Paris here, and I think that's all. So what I'm going to create is first the bike NFT contract. I say that we have already created this one entirely in a previous episode, including some graphics and IPFS stuff. So in this case, I'm just creating a very basic NFT. So actually, I'm just going to copy paste it because it's almost self-generated code where I'm just calling this a bike NFT token, bike N, to distinguish it from the bike ERC20. And in this contract, I'm just minting just a demo bike to myself for later to try to interact with the application. And this is just the random public key, which for me is the ID of the bike. Just to touch quickly on this, right? This is a public key because the bike has to sign messages. So most probably the bike hardware has some private public key pair, and the public key is unique and safely stored into the bike. And this public key somehow identifies the bike. And so when we mint the NFT, the token ID is this public key, which is the public key of the hardware that's on the bike. And then it's used to sign the messages later. And so, yeah, just minting this hypothetical bike to me. This is just example code. Nothing too special. I think I've customized this one to just mint with a custom token ID. That's it. Moving to the more interesting contract, the bike token. So this one is an ERC20 token. It's again, it's ownable, and I'm also importing the ERC721 because we are going to use the NFT contract of the bikes. So yeah, let's call this one contract bike sharing token. And it's ERC20, and it's also ownable. Okay, we need to store the ERC721 contract for the NFT. We have just a simple struct to store the information about a ride. So we have a struct ride, which just contains the address of the rider, the bike ID for this ride, so uint 256 bike ID, and we have how many tokens the user actually deposited. So uint 256 amount deposited. That's it, pretty simple. Up to the viewers' creativity to make it more interesting. So we want to, of course, keep track of all the rides, ongoing rides. And this is basically just, yeah, we are also assigning the ride ID automatically. So we have a uint 256 ride ID starting from 0. And we have a mapping from the ride ID to the actual ride data. And we call this one rides. Okay, then we have a couple events that we want to emit. These are pretty straightforward. We emit a ride started event where with the actual ride ID that's generated, the address of the rider, the bike ID used, and the amount deposited. And this one is emitted when the ride is started. And the mobile application is watching for this transaction to emit this event to collect the ride ID. And then probably we have a ride ended event, very similar, when the ride is completed. Okay, constructor, we need the address of the bike NFT contract. So address bike NFT contract. Now let's say bike NFT address. And we initialize the ERC20 constructor with, let's call it bike sharing token. And the symbol can just be bike. We are also initializing the ownable interface with message.sender. And I think this is it. I guess we just initialize the bike NFT contract with the IRC21 bike NFT address. And let's also mint, let's mint some tokens to myself for the demo, which is just mint, let's say to message.sender. That's 1,000 tokens by 18 by decimals. Okay, that's pretty straightforward for the constructor. Okay, one simple function is start a ride, right? Start a new ride. So this is just a function, start ride. When we start a new ride, we say we want to know the bike ID, right? So uint 256 bike ID. That's the one that the user scans with the QR code. And uint 256 deposit amount. And this is also coming from an estimation from the mobile application after the user plans the ride. So this should be enough or a little more, a bit more than it's needed for the ride. Okay, so we do perform the token deposit, right? Deposit, which is transfer from the sender for to the contract and the deposit amount. However, actually, we should make sure this user has the tokens. So we should also require that the balance of the message.sender is enough. Require is enough. So deposit amount. Yeah. Then we transfer. And after we transfer, we deposit. So the deposit is successful. We create, right? We create a new ride with rides. Ride ID equals ride. This is the message.sender is the rider, the bike ID, and the deposited tokens. We increase the ride ID for the next one. And I guess we, before we increase, we emit the ride started event with ride ID, message the sender, and the bike ID, we also need it, and the deposit amount. This is the ride started. Pretty simple. Probably also not working. Who knows?
No, never. It always works, I promise you.
Anyway, we're not going to test it today, so we leave it to the viewer.
Yes.
And function and the ride. That's when the interesting stuff happens. So and the ride. So this one is actually called by the IoTeX infrastructure upon proving some data. In this case, we are not really scaling that much. We are proving just a single message. So, but in a real application, the IoTeX infrastructure will collect many messages in this application and prove an entire batch of these messages and send a single proof. So after verifying the proof, you should also then apply the token economy to all the public data. So all the actual results without verifying anything because you verify the proof. In this case, it's just we assume we are receiving as the proof for a single ride, for a single message. So we are getting the ride ID. So and the ride ID, let's say ID, and we are receiving the cost for the ride. Cost. So how much was the ride, and we are receiving the actual zero knowledge proof that we can trust this data is true because it was originally sent from a trusted bike over the IoTeX infrastructure who verified the signature and then generated the proof, verified this data, and then it's sending over the data and a ZK proof. So bytes, let's call data proof. Okay, and it's a public function, of course. So here, the very first thing you want to do is verify the proof. So I'm not actually diving into this aspect because I'm just anticipating that if we complete this linear series, we are going to use a risk zero for this example because the IoTeX layer 2 like rollups, ZK rollups supports different ZK frameworks depending on what the project wants to use, also depending on the requirements. So in this case, I find like the risk zero framework to be extremely powerful and also very simple. So definitely great for a webinar or for a demo. So this will be a risk zero proof. And so at this point here, you are going to require that you verified. So let's say verify proof. Otherwise, just revert with invalid ZK proof. Okay. And this verify proof is just very basic, just empty, right? This one, that's where you are going to call the risk zero verifier that should have been deployed and is also part of this project. And it's the actual zero knowledge verifier for the prover who generated this proof in the IoTeX infrastructure. You create that verifier when you actually develop the IoTeX infrastructure part. So assuming that zero knowledge proof is valid, then you are just collecting just retrieving the information for the ride that was completed. Right? And at this point, you need to have the bike owner, right? That's where we use the NFT contract. So we need to know who was the owner of the bike for this ride. So we use the bike owner NFT owner of to see who was the owner of this bike ID token. And then, well, we should also revert if there are any issues here, but let's ignore issues. There should be no issue. And so, and once we have the actual owner, we can actually transfer the payment. So transfer bike owner the cost, the ride. And of course, we should. I mean, we assume that the user has not like spent more than what they deposited, but there should be many other checks probably. So, and of course, we are going to transfer the change. So to the ride dot rider, we're going to transfer the ride dot amount deposited minus cost. And or maybe you want to also keep a fee for the contract or whatever. And then just clean up the record with rides ID, or just delete it. Rides ID. Okay, I see a couple errors. Let's take a look. This is of course public. And we have another issue here. You int 256 bells transfer from transfer from.
You're brave. I always copy paste when I live code. I'm like watching you type this out. I was like, my heart is.
Transfer. Great. Excellent. Yeah, at this point, everything should be fine, I guess. So the first thing we do, we deploy the NFT. This contract, the NFT contract, should be deployed in the very beginning of the project when you have like the manufacturer for the bikes, and each time a new bike is manufactured and like shipped to an owner, the NFT is minted and transferred to the owner. And we have the contract address of the NFT, and so we can deploy the bike ERC20 with the address of the NFT. Transaction will likely fail. Why you want to fail? Deploy bike. Let me check. Why it wants to fail? Let's see. I think that remix ID is just somehow frozen. Let's try again. Contracts, and now we write everything from scratch.
Oh, I was about to be like, autosave. I don't know.
No.
Did you guys grow up in the days when autosave didn't exist? I remember that.
Bike, let's try again. Deploy here, deploy. I should select the provider, deploy. No, let's send it anyway. Let's see what happens. And otherwise, it will fix this one.
I mean, it said likely. It didn't say will 100%.
That's true. However, I see
I
that
just noticed that you were on a
the
live stream.
transaction was sent with zero gas, so I don't expect this to go anywhere. I just cancel. Okay, that's when you don't copy paste. You get the issue, and we probably leave this one as an exercise for viewers of the live stream to find the issue. Yeah, this one was correct, and this one FT back contract. Yeah, we'll leave it to the viewer, I guess.
We'll find out.
Because this was anyway the end of the like this first part where we deploy the DApp, and then the next part, if the like attendees are interested, we are happy to complete this project with the ZK prover, and then putting everything together and see how this can actually work for real.
Yeah.
And we will also disclose the winner of the contest of finding what went wrong
yeah.
today.
Yeah, let's send out a few IoTeX to the winner.
Oh, yeah.
Or a special NFT, or
Yeah.
Cool.
So comment under the video with the solution, and I would say the first one will take I don't know, 1,000 IoTeX. That's not that much,
Yeah.
but developers are not here for the money, right?
Yeah.
Okay, cool. So just to kind of I guess Dirk, who was asking the questions before, just wanted to expand past the bike sharing network. Let's just talk about IoTeX in general. Has applications for, I think he was asking about like solar, wind farming, kind of electricity generation and token economy on top of that. Yes.
Yeah, I saw the question. It was really interesting. I don't think that the bike concept is limiting, but I think it's basically kind of like the same thing. So he's talking about, could there be like other project, and maybe instead of bikes, we're talking about solar panels, or maybe wind electricity generators. Totally. And we do have actually projects that do that right now. And we have some examples as well for developers, but the idea is the same. People can contribute to the network with maybe solar panels, and then they take this, the service that provided is basically energy, and then this energy can be put back in the grid, and it can be shared among the network, or it can be sold maybe to third parties. So there are various verticals within deepen projects, as I was sort of saying at the beginning, that this can be mobility. There are like applications. Simone, in the meantime, is still
I'm sorry for the viewers, but I guess I already fixed it.
What was the
Okay.
problem?
No,
The
no,
start,
1,000 either.
the start ride function should be, of course, payable, because the user should deposit something. But yeah.
Okay, so sorry, users, sorry, viewers, you will not get 1,000 IoTeX, nor any NFT that we were casually just dropping. But yeah, there are many verticals, and the projects, like decentralized computation, energy, smart home, mobility. There is a lot of innovation at the moment, and it sort of like takes us back to the first slide, where there are dozens of people trying to sort of like disrupt the vertical in which they're in, and it's really interesting. So Dirk, yeah, definitely a great point. And it could all be achieved, using the IoTeX modular stack and the devices. Correct.
Cool. And then I wanted to touch on one thing. I think you offhandedly mentioned, Simone, and let me know if I'm wrong. You're talking when we were doing the end ride part, I think Simone, you said, oh, this doesn't really matter because we're only sending it once. But the whole point of IoTeX here, right, is if we have like 1 million people ending their rides at the same time, that's when IoTeX matters, right?
Yeah, exactly. And not only that, but if you want to actually prove something more serious, right? For example, that you have been riding across a specific path. Think if it's like a car sharing and not bike sharing, and you want to prove that you have been driving far from the center, right? Or then you probably need all the data along the ride, and then you need to collect all this amount of data, which is itself not needed to go on the chain, right? But all this amount of data will prove something.
Yeah.
Still, and that's the proof that you need. The proof of the insight. You need some insight on top of this data, and this insight should be verifiable. The data should be verifiable. That's why the device is trusted. So it has some sort of hardware and stuff that we have discussed in other episodes. So the data itself, each single data point is verifiable. And then you compute an insight on this data. Could be you did actually drive far from the center, right? So this insight can be computed into the infrastructure on top of all these data points, and then generate a single proof of this fact, and this proof goes to the blockchain. And then, yeah, just the rest of the data can just be either discarded, stored, whatever, depending on the project requirement.
Okay. We are over time. So
Yeah.
I know we probably will have a part 2 to do the actual sexy stuff with the proof
Cool.
and the sending and all of that.
Definitely.
But I guess in the meantime, I'll add the other episode links to the description on this YouTube, and then separately like links for code, and if there is interest in the PowerPoint slides, we'll also share, I guess, in the description on Twitter, other places.
Yeah, we totally can. No problem.
Okay,
Sounds
cool.
perfect.
Well, thank you so much. I hope to
Thank
see
you,
you guys
guys.
soon. This was really interesting.
Thank you, Emily.
Okay,
Thank you.
cool.
Thank you. Yeah.
Good day.
Bye.